Hope you guys are enjoying Dreamforce so far. Thank you so much for being here with us. We're going to be talking about Einstein Vision and language, and specifically how to automate and streamline your workflows. So my name is Zineb Louraki. I'm the Senior Products Manager on the Einstein.ai team. So we work on language, vision, and all the voice stuff that you've been seeing. And Mike, I'll let you introduce yourself.
Sure, thanks, Zineb. Hey, everybody, thanks for being here. My name is Mike Salem. I'm a Principal Solution Engineer here at Salesforce, and it's my job to work with customers on how they can get started with Einstein Vision and language. Thanks again.
So just before we get started, forward-looking statement. As you guys know, please make your purchasing decisions on products that are currently generally available. The good news is we're going to be talking about products that are generally available, so we don't have to worry about this too much today. So what specifically we're going to walk you guys through is, first we're going to start up with an overview of Einstein Vision and language. What are these deep learning services and how do you use them? And then we're going to talk about the keys to a great data set and then specifically agile AI. We want you to leave this room having the tools and processes to be able to successfully leverage these deep learning services. So that's really our goal today. So with that, maybe just to kind of set the stage here, as you might be aware, we're creating a lot of new types of data, so image, text, and voice. And until recently, we weren't doing much with this type of data because AI wasn't really there to be able to understand the patterns in this more complex types of data. Now we're at a time where the deep learning neural nets are able to understand the patterns in this type of data and allow us to derive insights from image or text or voice. The reality, though, is this is still very hard to use. These computer vision, NLP services, they're available, but deep learning is not as easy or as accessible as it could be. And that's really where Salesforce stepped in. And we're like, let's provide these deep learning models as a service. And so we started by providing two categories, Einstein Vision and Einstein Language. So under Einstein Vision, we have image classification. So this allows you to train your own computer vision models very easily by just putting images in folders, and you define the categories, and then you give it new images it's never seen before, and it'll be able to tell you which category that image belongs to. Einstein Object Detection is a little more advanced computer vision functionality, and what it does is it allows you to define the objects that you want your model to understand, and it's then able to tell you where in the image those objects are, what their relative size is, and you can even do things such as counting the amount of objects, and we'll talk about a few use cases for object detection as well, and Michael will run us through a demo. On the language side, we have Einstein Sentiment, which is a pre-trained model, and if you give it an utterance or a text, it will tell you if it's positive, negative, or neutral. And then Einstein Intent allows you to define the categories that you want. So is this a support issue? Is this about product A, product B? Is this support for password help or damaged product, right? You define the categories, and you then give it text, and it'll tell you which category the text belongs to. And with these services, we're seeing customers unlock value across multiple industries. So in Vision specifically, we're seeing people use it for brand recognition in social media. So specifically, it's provided as an out-of-the-box solution in Einstein Vision for social studios. We're seeing customers use it in sales and service, so being able to identify products or parts and use that to streamline their sales or service workflows. We're seeing being used in insurance and being able to detect damage or severity of damage in cars or other home or other insurance kind of use cases.
Z, real quick, so if any of you were at the financial services keynote earlier, State Farm actually talked about how they're using object detection within their own warranty and auto adjudication claims. So we're seeing it in the wide variety of insurance, automotive, lease returns, things like that. It's really exciting. Yeah,
and I think Toyota as well was talking about this use case in the Einstein keynote.
Yep.
So we're seeing a lot of use cases. Retail execution is another big one that we're having. So being able to automate store auditing, so understanding share of shelf, on-shelf availability, et cetera. On the language side, we're seeing customers use our services for chatbots. So if you've seen any of the demos of Einstein chatbots, that uses underlying the NLP, that uses the services that we're talking about today. Einstein Voice, or Einstein Assistant, that also uses the NLP services we're going to talk about today. We're also seeing customers use it for customer service, so automatically routing cases to, or triaging cases to the right agents. And then also, one last example being surveys, so understanding the types of insights or sentiments that your customers are providing in your surveys. So no matter if we're talking about vision or language, the process that you go through is very similar. The first step is you need to gather your data. The second step is you need to upload and train your model. Third step is to test your model and improve it. And then finally integrate your model and improve it over time. One of the things that we keep telling customers is don't worry about if it's possible, just figure out the problem that you're trying to solve and we'll help you solve it, right? We'll help you with the technology to actually achieve that computer vision or NLP use case. And so actually with that, Mike, do you want to show us how this actually works?
Yeah, so I'm going to walk you through a demo that we would be considered, what you would use out in the field, out in production. It'll be a mobile demo. You'll see Einstein object detection in practice. And then I'll flip over and give you a look into how we would put a model like that together, how we would integrate it into our apps. And then we can kind of talk a little bit more about how I got there. So the first thing I'm going to do is flip over to my phone. Can you see all that?
Yep.
Okay. So set the stage for the demo really quick. Let's say that I work for a wholesaler who supplies retail products to different retail locations out there in the world. And part of what I have to do is I have to travel around to some of these retail locations and make sure that the products on the shelf are displayed in the right way, see kind of what my competitors are doing, how they're being displayed, and even see if the retailer is displaying it in compliance with the planogram that we've set up. Now, because we have a lot of information in Salesforce, we've been able to tell which planograms we're using across the country, and we're also able to tell which planograms are resulting in the highest sales. So when I travel out to some of these retail locations to check on my products, I want to know if they're laying them out in a way that will maximize the amount of sales that they'll be able to have, again, because I'm able to see this across the country. Now, historically, this took a long time, both to do and to ramp new employees on how to do. We had to do things like compare what was in notebooks and catalogs to what we're seeing in front of us. The employees were supposed to know what products were supposed to be laid out in what way. But now we can educate Einstein on how all that should work so that all the employees have to do is show up and take a picture and have this type of virtual assistant enable them in their work so that we don't have to spend so much time and money training and executing on the work itself. We can move that much faster. So I'll start by selecting one of the locations, once I unlock my phone here, that I'm going to go inspect. It'll be this Lakeview location. And this is a Salesforce flow within the Salesforce One mobile app. But what's important to note here is that the kinds of things that I'm showing you could work in a third-party app as well. This just happens to be Salesforce One. It also could work on the web, mobile browser, things like that. The next thing I'm displayed with is where in this retail location do I need to make sure that I inspect. So again, we're guiding the employee in what they should be doing. And here's where Einstein object detection starts to come into play. So I'm standing in front of some shelving units, and I'm going to go ahead and just take a picture of what I see in front of me. So if you were in the Trailhead area earlier today, you might have seen a demo pretty similar to this one. Einstein will analyze the shelves it sees in front of it. You can kind of see what's going on. And so this is an example of object detection. And think about how fast that just was. That was 3 clicks and about 5 seconds to get to this part of the flow. And we can see some things immediately. We can see what brands are located on the shelves. We can see the percentage shelf. And we can even see how they're laid out. So there's actually 2 computer vision models happening simultaneously right now. One is the object detection model, pointing out what specific objects are in that picture. In this case, the different types of brands and products that are laid out on the shelves. The second one is an image classification model. And what we're saying is this picture compliant or is it not compliant? And that's where you can see the second row there on the Einstein analysis that's being returned. So we can see that it's not compliant with the planogram that we've laid out that this retail location is supposed to be displaying in their store for our products. And so we can go one step further. AI is cool, but it's all about how can we make it a virtual assistant? How can we enable the business and the users who are using it? The hero of these stories isn't the machine itself, it's the people who can act that much quicker and that much better with the use of these types of virtual assistants. So now we can see that here's the actual layout. And if you just take a quick look, you can see 3 blue boxes on the top and a green one, which is very different from 3 yellow on the top. So we can very easily kind of compare and contrast that. So 2 AI models, object detection for what's in the picture, and then image classification for compliant or not. So let me show you an example of how we might get there. And to do that, I'm going to go back into Salesforce. Z, if you'll give me a moment, I need to log in. I'm just going to log into my Salesforce Service Cloud instance. Resolution is super small. Yeah, I know. You're telling me I'm having a look at this thing. So with Einstein, we have this Einstein platform app. And because this is an API service behind the scenes, one of the things that my team has worked on.
Can you zoom in?
Oh, yeah. Okay. Let's try to do that. How's that?
Much better.
Much better? All right, cool.
Thanks.
One of the things that my team and Zaneb's team are working on is how do we provide some administrative style UI features that overlay the API services behind the scenes. And so one of the things we want to do is we want to be able to get up and running with these models very, very quickly. We don't want it to necessarily always be command line or programmatic. It can be if that's what people want to do, but we've also exposed this kind of UI layer on top of the services that we have out there. So if I wanted to make something similar to what you just saw on my mobile app, I'll just show you an example of image classification. The first thing I would do is upload a file of my data set. So if you remember Zaneb's slide earlier, she had steps 1 through 4, and the first one was gather your data. So I'm moving one step past that. Let's say that I have my data already, it's in a zip file, and I'm about to upload it into Einstein. In a minute here, we'll talk about how you might even go about creating that zip file to begin with. But the first thing I'll do is upload my zip file. The resolution is crazy small right now, but bear with me that is indeed a zip file, and I would upload it. Now, depending on the amount of images you have, the size of the file, it could take anywhere from 30 seconds to somewhere less than 10 minutes. As it would go through uploading, I'll just show you the next steps that we would do for an already completed model. So after my data set is uploaded, I can check it on my Datasets and Models tab. If you look at the bottom here, we have our Crossmark Dreamforce 18. That's the image recognition model that I just uploaded. And I can check on the details for it pretty quickly. So after that model uploaded, after that zip file uploaded, the only other thing I would have to do is click this train button. So what that's saying is all the images are in Einstein, and when I hit train, we're telling Einstein to look at everything that's in there. Look at the images that have been labeled compliant, which you can see here on this row, I have 172. I'll make that a little bit bigger also. There we go. 172, and then look at the labels, look at the images that are labeled as non-compliant. I have 282 of those also. This is also giving you an idea of the number of images you might need just to get started. A little less than 400 there. And as I'm analyzing these images and putting them into the right folders, if I wanted to quickly just test what was going on to make sure that the model is working the way that I would hope it is, I can also just quickly throw some predictions in there. So we don't have to wait until it's integrated into the mobile app. As part of this UI layer, we can just test these kind of things on the fly. As Einstein is analyzing this one, the last thing I'll show you, and this is kind of where the rubber meets the road, is once the data set's been created and trained, what Einstein gives us is a model ID. And that model ID is how you link this type of AI computer vision technology with your mobile or your business applications. So you can see this was the same image. It's coming back as non-compliant. That's the image classification model. And what it's really doing here is when I upload that image, it's saying, take the file or I'm telling Einstein, take the file that I just gave you, bounce it off of that model ID, which represents that less than 400 image data set that I have, and tell me which one of these it matches up to. So that's how we can do things like compliant or non-compliant. That's how we can do things like fraud detection. That's how we can get pretty granular with a lot of these types of models that our customers are wanting to create. If you wanted to do object detection, similar kind of stuff. You're actually pointing out where in the picture you want Einstein to analyze. But this is a brief overview of what a mobile, production-ready AI application can look like, and then a few high-level steps on how you might get there. So, you have anything you want to add on any of this before I get into?
No. Can you tell us a little bit more about how to start? Like, what's the data set? Like, What are the keys to starting with a good data set?
Good question. So I'm actually going to go over that next. And if I can have the clicker, please. Thank you. Okay. So at the beginning of this, we mentioned the 3 topics we wanted to cover. The next thing I'm going to go over is how do we even get to that zip file that I started with to upload? What are the keys to creating a great data set? And one thing I want to point out is that what we're about to talk about isn't just based on how Zeneb or I think things should happen. This is all based on over a year's worth of work between the 2 of us working with actual customers on helping them get their computer vision and their NLP models up and running. So these are all examples and questions and things that we've seen, potholes that customers have run into that we've helped them be able to work through. So these are all what we actually see in the real world, and that's what we're going to go over. So as much as we would like any of our AI models to be like Tyrion Lannister from Game of Thrones and just know things, which is what quite a lot of people expect should happen with AI, we actually have to educate it. We have to teach it from the ground up. And the important thing to realize is that it literally only knows what we've specifically taught it. And in some cases, that may seem counterintuitive. But I'll give you some examples on what that could look like and how we actually can go in there and fix it. So to illustrate this concept, let's talk about how we might educate a toddler on what an apple looks like. You're going through the grocery store and things like that. Well, would you give the toddler some sort of theoretical, abstract, verbal explanation of curves and an apple is smooth to the touch and it has a stem and it's these colors and just be very scientific about how you're speaking to that toddler? Does anybody have an idea, yes or no? No, exactly. And when we start with these custom AI models, it's very, very similar. It's like every one of our customers' org has a toddler in it that we have to educate and rear and bring up so that it understands what it's supposed to know about the world. So how we would actually educate a toddler is we would go around and we would point out examples over and over and over again about what an apple looks like consistently and over time until the toddler itself starts to understand, okay, that's an apple, that's an orange, that's a pear. And the key is images over time. And from a computer vision model, what we start to get into is when we submit images to Einstein, it looks at things like each individual pixel. It starts to find the edges, make sense of those edges until it gets into the actual object parts and objects that it's supposed to understand within that image. But from an application perspective, what we would actually do is we're just feeding Einstein images consistently and over time until its understanding starts to grow and grow, until it starts to know everything about what we're sending it that we would want it to understand. So let's look at a specific example. Let's look at a data set that has apples and that has pears. And about the apples, does anything about this immediately stand out to anybody? Anybody want to take a guess?
All the apples are the same color.
Exactly. And not only are they all the same color, they're all on a white background, and they all have green leaves as a part of their stem. So 3 things that are all extremely similar, color right now being probably the most indicative about what's going on here. So within this current data set, what do you think would happen if we sent it this picture? Do you think it would get it right or it would get it wrong? And what do you think it would think it was? Exactly. Because it's never seen a green apple, and Einstein in this case, or any computer vision model, has never seen a green background. So we might think that's kind of weird. Why is Einstein categorizing this as a pear? It's obviously an apple. But remember, it only knows what we've taught it. And right now, it only knows that apples are red and that pears are green. So let's look at this data set. And this is where we're going to get into the idea of representative data sets. That's one of the takeaways that we want for you to take from this session, the idea of representative samples and representative data sets. The apples in this example are all different colors, green, red, yellow. They have different kind of backgrounds. We have green in the background. People are holding the apples in some of the pictures, different kind of angles and shapes of the apples themselves. And we kind of tried to do the same thing with the pears, but the apples are the focus for right now. So now what would happen if we sent it this? Anybody want to take a gander? I think it would get it right. And the reason being, in this example, we don't have a green apple with a green background necessarily, but we have shown Einstein green apples, and we have shown Einstein apples with green in the background. So we can start to extrapolate on things that's seen in the past and learn from in the past to accurately predict things in the future. Everybody with me so far? Is this starting to make sense? And remember, these are the types of things that real customers are going through today, that we're working with them on a daily basis. So the next thing I want to talk about is not only, when we talk about representative, not only the variety of the images themselves, but how you structure the images, how you take those pictures, and just kind of overall where those images are coming from. So another huge concept that a lot of my customers right now are going through and kind of working through is this notion that their image data set has to be from a location that is something like this, which is professionally designed with professional cameras and professional lighting, white backdrops, pristine, mint condition, everything. Because the thinking kind of up until now has been, well, we want to give the AI model the best possible view to see every little nook and cranny of this image so it can learn in the best way that we can give it. And if you look at the actual pictures up there, let's say that just theoretically, in general, this is a field service use case. Let's say you have people out there in the field. They have to take a picture of the things that they might be working on or replacing or fixing. And they want some additional help so that they don't have to automatically just know what all these different types of objects are on their own. Again, going back to the thing about onboarding new employees and the type of education and training it takes to make them functional. Well, again, in this example, all these parts have white backgrounds. They're all in mint condition right after the factory floor, and they're all facing the same angle. So this notion of just pristine, kind of pure professional production quality of the images. So similar notion to the apples and pears, what do you think would happen when this guy sends in an image that looks like that on the left? This is what's going on a daily basis and is one of the biggest light bulb moments for our customers because it's just not something that they've thought about in the past. In the previous example, this example, Einstein has never seen an image coming in from a mobile phone. It's never seen a product that's been greasy, dirty, or broken. And with this kind of example, there might be blur in the image, there might be a smudge on the camera lens, this guy's thumb might be covering something. And so it's just as important to take what might come from the field in the future, examples, and use that in your initial data set. So red and green, apples and pears, but also pristine and not so pristine when we're talking about things that might come in the field. And I'm not necessarily saying that you should use these types of images in your training data set all the time. What I'm saying is, if this could come in the future at some point, use images like this as part of how you train your model in the first place. Just like we talked about a green apple with green in the background, well, if Einstein has seen a part that can be greasy or broken in the past, it's that much more well-equipped to correctly identify a part that's not in mint condition in the future. Fair enough? Okay. So the next thing I then get asked is, okay, we kind of get this whole what is an apple concept, but how do we even get started? Should we shut down operations for the next 3 years and just go take pictures of everything and think about every possible situation and every possible way that an image might come in? Definitely not. Nobody could realistically be able to do that. And so the next thing we start to talk about is this notion of agile AI. We like to think of it as like minimum viable data sets, which Zeneb is going to get into next. And how can we get up and running fast, small model, and kind of grow and provide feedback from there. So, Zeneb?
Awesome. So, just to start off, maybe to draw kind of a comparison between software development and AI, or how you need to think about these models. How many of you guys are familiar with waterfall methodology? Okay, so most of you guys. So for those who aren't, it's really this software development methodology where you kind of have milestones that build up on each other, where at the end you have a final product that's usable. In contrast, agile methodology is where at each milestone you have a minimal viable product, right? A product that has enough functionality to be useful. So even though we're starting with a skateboard and not a car, right? We're not getting to the car the first step. We still have something that's useful, that's solving a problem for users, right? In a very similar manner, that's what we encourage customers to do when they're building their AI models. Really think about how can you start with your MVP? How can you start with the subsets of the categories that you need, or maybe larger categories and then break it down as you go along, instead of trying to boil the ocean to start with and try to have your model cover all your use cases. That's just not a realistic way to start. You're not going to have necessarily the data sets. It's going to require you so much upfront investment. It's really not the best path forward. And so really thinking about milestones and chunks where each one is something that you can use out in production and start getting feedback so your model can improve over time. So let's take a look at what that means. So let's go back to this example of this model that we have that knows apples and pears. And once again, similar to what Mike said earlier, we're talking about vision here, examples just to illustrate it, but these concepts apply to both language and vision, right? So once again, we have this model that understands apples and pears. So let's say we ask it, what is this, right? And at the beginning, before we had given it examples of green apples, it thought this was a pear, right? So one way to improve this model, right, over time to add that data set, because you might be like, I only have examples of red apples to start, right? I only have examples of my product in this use case, right? Not in all these different use cases. So what you want to do is provide what's called a feedback loop. So you let your end user correct things or tell you, actually, no, this is wrong. This is actually an apple. And you save that, and you then use that extra data point to increase your data set so that it improves over time. So now I know that this green background and green apple here is actually an apple. I'm able to add that to my data set and improve it over time. So this next time that it sees an apple, it's not the same one that we saw before, but a green one, it'll correctly predict that this is an apple. Now, to kind of take things a step further. Now, the reality is, let's say, if I have my model that just understands apples and pears, it's always going to predict that whatever I give it is either an apple or a pear. That's all it knows. In its world, that's all it knows. So if I gave an example of an orange, in this case, it'll think it's an apple or a pear, right? So what we recommend that you do in this use case is add this category of other. And the technical term for this is usually a negative data set, right? It's this notion of having, if you know that your customers are going to provide you examples, either pictures or text that might not fit into the categories that you have defined, you can have this like catch-all bucket, if you will. That's other. And that's like really important, especially if you're having end users do it, because you can't control what they're gonna be giving you, right? And so you basically create this bucket of other. And at first, this bucket of other might actually not work very well, right? It might get things wrong. But once again, you use the same concept of feedback loop so that you let your users tell you, actually, no, this model is wrong. This is actually an orange or other, right? And so your model will then be able to improve over time. And next time that it sees an orange, even if it's not the exact same, picture, it's able to say, oh, this is actually other. This is not an apple or a pear. Does the concept of negative data sets make sense? Yeah, cool. So taking this a step further, what you can do is also use this to grow your data sets over time and grow your categories over time. So this is kind of what an admin would see, right? So you probably want to add, depending on who your users are, you might want to add a quality assurance step, right? Where an admin reviews the corrections before they're used to train your model, right? And goes into production. And so let's say here I'm an admin, and what you can notice is at first Einstein, so the first column is the picture that people sent, right? Took or sent and asked you what it is. The second column is what Einstein predicted, and the final column that you see here is the feedback. And so you'll notice that at first Einstein was predicting that the oranges were an apple. But after a while, with enough feedback, it's been able to know, well, actually, it's other, and it's predicting it correctly. Now, as an admin, what I might take things a step further and realize is that, whoa, I have actually a bunch of examples of oranges. People are taking a bunch of pictures of oranges, right? And so what I can decide to do is basically create a new category, add a new category to my data set that's orange. And at this point, I already have a bunch of examples to seed for that, right? And so it's really kind of thinking of this, instead of starting with all of these categories at the beginning, where it's a lot of investment. This is easy like apples, oranges, but think about your products. It might not be that easy to collect the data for all of your different hundreds of categories. So you start with a subset of them. Start with 50, with the most used ones, the ones that address most of your use case, and then kind of grow from there. And so basically, when I see an orange, now it's able to predict that it's an orange, right? And you can kind of continue growing from there. So to summarize, we basically went through what Einstein Vision and language are. These are deep learning services. We made them very easy for you guys to use. Mike ran us through a UI that's going to actually be available on App Exchange very soon. So it allows you to train your models through click, not code. We didn't show you model metrics, but those are there as well. And we have great documentation in case you need a little more hand-holding, as well as trailheads to use these services. And then the other two key concepts that we went over is this notion of representative data. So models only know what you teach them. You want variety, right? You want the use case to be representative of what it's going to see in production. And then you also want field quality. And finally, when we're talking about agile AI, really start thinking about your minimal viable data set. So instead of minimal viable product, you're saying your minimal viable data set here. Really think about how can you scope the problem correctly to have something that's useful to start with and grow from there. Because just trying to do everything as once is kind of going back to that waterfall, which is just going to take you so much more time. Think about it in agile, one step at a time, and really start small and grow. And then, of course, leverage your feedback loops. Get your customers and your users to provide you insights so that you can improve your models over time. Now, one other question that we get all the time is just how do I get started with my data set, right? Some people are lucky and you might have your data sets already in Salesforce or you have it historically. So for example, for cases, I might have all my cases, historical cases with tags, and I can use that to seed my model to train it. So if you have it, make sure to QA it, because if the labels are wrong that you provide the data sets for your model is going to be making wrong predictions. So make sure to QA it, but you can use it. But even if you don't have a data set, you might need to get creative and see if you can find data sets online. So sometimes there are free data sets online that you can use, and sometimes you can buy them. So chatbots, for example, is kind of going the marketplace route where you can purchase data sets and import them to kind of seed your chatbot model. So I think you're going to start seeing more and more of that as a real option. And then finally, if first two are not really feasible, really just create it. It's not that much work. It's often very daunting for people when they're starting because you're starting with a blank page. But really just going out there and collecting the images or sitting at your desk and making up the examples really gets you to that first milestone. They really can get you there. So don't be scared to just get started. It's not as much work as you think. And so with that, you can sign up for these services for free on Einstein.ai. There's some demos both upstairs on the 3rd floor on the Einstein Ridge, as well as downstairs in the Trailhead Park. And then, of course, we have the Einstein Trail Mix that covers all of the topics that we went through today, or all the services we went through today. We have a few more minutes, so if you guys have any questions, please go ahead.
Just a couple, if I can take the question. First, thank you for the Einstein platform product. I'm glad it's coming off GitHub. We have it, we're using it in production for case classification with a human in the loop. Now it's not 100% AI. But is there any plans to increase the number of words that are allowed on language API?
It's like 200 right now, right?
Higher?
Like for entire bodies of text, like a paragraph?
Right.
I'll let you take that, Z. She's the PM.
That is something that we're looking into. It's not in the immediate roadmap. What is your use case, out of curiosity?
I'm doing case classification.
Okay.
Granted, only 5% of bodies of case classification, and you want to include as much of that text as possible. That's I just.
Yeah. No, and thanks for letting us know. That definitely matters to us. So it's definitely something that's on our roadmap. So thank you for that feedback.
What we've seen some customers do, just as a workaround in the meantime, is in Apex, you can break up the text like by period or something, so that as you see it, like if you every third period or something like that, if you have a paragraph, you can split it out into 2 different rows. That way you could run different models or the same model on each body of text to keep it under 50 characters each, and you can classify that one case in multiple ways. Because often when we have a paragraph, you know, if it's a case or a survey or an email or whatever, that person can be going all over the place.
Right.
So it could be classified in multiple ways very, very easily. So until that's a feature that we have as a part of the product, the biggest way that we've seen customers handle that is break it by a period or every other period or whatever, and then run the model on it a few times.
And that's actually what we do for Einstein voice assistants that you guys probably seen demos of, is we break it up by like point break and run the intent model on each section. Because as you're saying, right, usually if you're going on for a while, it usually covers more than one topic.
Can I ask a question about the convolutional neural network that you're using for image classification? Are you using like pre-trained base on something like ImageNet or something like that? So if I start throwing satellite data at it, is it going to be able to handle that, or is it more of or is it just totally naive and I build it from scratch?
No, it's not totally naive. We do have some pre-processing and post-processing steps before you even start using it, and that's why you actually don't need, depending on what your use case is, you don't need that many examples, right, to start off. So you're not starting from scratch. Yeah.
Yeah, if you remember mine, from my demo, we had, I think it was right around 300 images.
And that's a model that is.
We have that going. It's, you know.
So are you doing data augmentation as well on those smaller data sets?
We do have data augmentation functionality, and so if this is something that you're interested in, definitely ping us and we can tell you how to kind of leverage that. We're looking to kind of making it more accessible and more available, basically both looking at data augmentation as well as using some global models, so that basically trying to relieve some of that burden of trying to train your model, right? So needing less images.
I just wanted to say thank you for a great product.
Oh, thank you. Appreciate it.
Awesome Salesforce products ever.
Oh, thanks.
That's right.
So I have a couple of questions. First one is on image classification. The demo that you showed for the planogram compliance. Question is, every store will have a different compliance image. So how do you make sure that you train it for that store? Did you do that, or is that different?
So
yeah. Sorry, go ahead.
Well, the way that so what I just showed you is an in-production application. There's customers of ours right now that are doing that for real out in the field. Crossmark is one of them. What you're asking, I feel like, let me just clarify it a little bit. I think what I hear you asking is that there's an assumption that a specific retail location could have different planograms per location. And that's not what I demoed, and that's not what some of our customers are doing. But to get to what you're saying, we could just as easily train a model per location or per region or per whatever. And then in that flow that I showed you, remember how I had the model ID? You can start to tie it together so that I can say, if I'm in this part of the country or if I'm visiting these types of stores, anytime an image comes in, bounce it against the model ID that makes sense for them. So that's not the way that I built the demo, but I could have just as easily built it that way. Yeah.
And the second question was around language. So when you, it's a bit similar to the question earlier, how do you parse text? Like when you are, and keep in context. So I talked about something earlier, and then I go talk about something else. How do you know that I'm talking about it in a minute about meeting her next tomorrow? And do you do that?
Not right now. So the way that you would do that is you would break up the text into multiple sections. Because every time you send us a piece of text, we tell you which category it's more likely. And so you could technically look at the first 2 categories or 3 categories and kind of makes, if the probability is high enough, right, we provide you a confidence rate for the prediction. So if you're like, they're close enough, it might be talking about these 2. You could do something like that, but ideally you'd break it up per section. And then just one thing about retail. Are you in retail? Is that?
Yeah.
So, the industries, our Salesforce Industries team is in the process of building a retail execution application that will have vision embedded in it. And so if that's something that you're interested in, definitely worth telling your AE to kind of get you in that pilot.
Can I find them here?
Sorry?
Where can I find them here?
Where can you find what?
The retail team?
Oh, get your AE to reach out. They'll be able to help you.
Yeah.
Other questions?
Is there something that, or, sorry, I don't know the right question, but I'll just try. But is there something limiting like us from utilizing engines that already kind of have some of that image capturing? Like, for instance, when I go on Google Images, there's tons, I can just Google apples. Can I borrow that and start just loading it into my engine? Is that
Totally.
allowed?
Yes.
Well, it
Well, I
depends
mean,
on-
it depends on if you're going to put it in production and using copyright and that kind of stuff.
You just need to be mindful of copyright issues, right? So some of the images that are on Google belong to someone, and so you can't just use them to build a model and then start using it for commercial uses, right? So you just need to be.
Probably buy something from Google where they would let me utilize those.
So there are, I don't know if Google offers that, but there are like, for example, we were working with, I think it was Shutterfly, and so we were using their data sets to train some of our models, right? And so there are options out there, both free as well as paid, that you can use people's data sets to train your models. Yeah.
Functionally, technically, however you want to phrase it, what I was describing a second ago was when you do have those images, if you think about compliant versus non-compliant in that zip file, what would be in that zip file is a subfolder for apples and a subfolder for pears. And in your apples folder, you'd have 100 or so images. In your pears folder, you'd have 100 or so images. So whether you get those from buying them from somewhere or you have them or however, you would structure your folder set like that, zip it up, and then you could use that to load it in. So whether it's non-copyright from Google or you've bought it from somewhere else, barring any of how you procure those on your own, we're not as concerned with how, like, what the images are, where they're coming from necessarily.
If we use voice, so is it possible to understand the sentient, understand if it's positive or negative, based not on the basing how it works, it analyzes what I said or how I said.
I like the intonation versus the words themselves. I'm gonna let you take that one.
Yep. No, that's spot on. And so sentiment analysis is something that's actually existed for a while. And back a few years ago, it was based off of word count, right? And so if a word was positive, it gave you points for positive. If it was negative, it uses negative. Now with deep learning models, what we're using is an LSTM model, which basically, to kind of simplify, it looks at not only the words, but the context of the word, of what comes before and after. And so it's able to actually understand things such as tone or even sarcasm in some instances. Now, the model that we have that's pre-trained is trained off a certain set of data. Now, what we allow you to do is actually evolve the model for your specific use case. So let's say I do AC, I sell ACs, and somebody says, this is the hottest market on the hottest product on the market. For any other customer, that might be a positive, but in my industry, that's negative, right? And so the model off the shelf might predict it as positive, but what you can do is provide that as additional training data so that it will learn for you specifically, this should be a negative statement. I think we need to get out of here, so we're actually going to stick around. We'll be right outside, so if you want to ask some more questions, we'll be right there.
Thanks all.